Dear students of class 12th, Assalamu alaikum. Today we are going to discuss the general properties of transition elements. As you know that transition elements are a group of elements which is located at the middle of periodic table. There are general properties of transition elements which are very close to each other, means they have same properties. Almost everyone has same atomic radius, and because of the same atomic radius they have same physical properties. A few general properties are discussed below. Number 1, these elements form colored compounds and ions. This color is explained by the d-d transition of electrons. Students, transition elements have d orbitals. The d orbital is split into two sections. One has higher energy and the other has lower energy. The electrons jump from lower to higher energy. When it comes back, it emits certain kind of radiations, and mostly these radiations are colored. For example, potassium dichromate is orange, iron sulfate is green, cobalt chloride is purple, and copper sulfate is blue. You can see these colors as given in the given diagram. Number 2, there is a relatively low gap in energy between the s and d orbitals, like 4s and 3d orbitals, so they exhibit many possible oxidation states. Students, because of low difference between the energy of s and d orbital, s electrons as well as d electrons can be released from their outer shells. Therefore, they show variable oxidation states. For example, in the given diagram, you can see the oxidation states of different elements. For example, manganese have 1, 2, 3, 4, 5, 6, and 7 oxidation states. The maximum number of oxidation states are of manganese because its all electrons can be released very easily. For example, 4 is 2 electrons and 3d 5 electrons. All these electrons can be removed from its atom, therefore it can show maximum +7 oxidation state. Number 3, many paramagnetic compounds are formed by these elements because of the unpaired electrons in the d orbital. Students, paramagnetic compounds are those which are slightly attracted by the magnetic field. When they are inside the magnetic field, they show attraction, but if they are removed from the when they are removed or they are taken out of the magnetic field, they don't show magnetic properties. Some are ferromagnetic, which have many unpaired electrons. Those which have many unpaired electrons, any maximum number of unpaired electrons, they show very strong magnetic properties, and they are magnetic even out of the magnetic field. These are the unpaired electrons which are present in the 4s orbital and the 3d orbital. For example, this one has 4s1 and 3d 5 electronic structure, and all these electrons are unpaired. That is why it shows maximum ferromagnetic properties. Number 4, a large variety of ligands can bind themselves to these elements. Due to this, a wide variety of stable complexes are formed by the transition elements. Students, ligands are those ions or molecules which can donate their lone pair of electrons to these transition metal ions. The transition metal ions have high charge density. That is why they attract the lone pair of these ligands and accommodate them around their atoms or around their nuclei. That is why they make strong and very stable complexes. For example, in the given example, we have manganese complex and copper chloride complex. We see that manganese has attracted by water molecules, while copper has attracted by chloride molecules. Number 5, these elements have high charge to radius ratio, so they can make complexes by accepting lone pairs from the ligands. As I have stated before, they have high charge density because of high charge and small radii. That is why they can make complexes by accepting lone pairs from the ligands. The diagram shows the atomic radii of transition elements. They have small radii and have high charge. That is why the charge density on these ions is very large. That is why they can attract the lone pairs of the ligands. Number 6, transition metals tend to be hard and they have relatively high densities when compared to other elements. Because of their small size and high atomic numbers or atomic masses, they have very high density. For example, they are very hard. The following diagram shows the cutting tools. These are made of transition elements like iron or steel, and they are very hard, so they can be used as cutting tools. Number 7, the boiling points and melting points of these elements are very high due to the participation of the delocalized d electrons in metallic bonding. You know that the stronger is the metallic bond if there are many electrons participating in it. So they have d electrons, and all these electrons are capable of making metallic bonds. That is why the metallic bond is very strong and they are very hard. For example, this diagram shows the metallic bonding where the electrons are located between the nuclei of these elements. These are delocalized electrons which can be responsible for the strong metallic bonding for the conductivity or electrical conductivity of the elements. Number 8, transition metals are very good conductors of electricity due to the delocalized electrons of metallic bonding. As I stated before, because of the presence of d electrons or delocalized d electrons, they are very good conductors of the electricity. Number 9, these elements are malleable, means they can be shaped into sheets. Malleable are those elements which can be shaped into sheets. For example, the following diagram show the sheets of metals. Such kind of sheets can be made of these elements. Number 10, these elements are ductile. It means that they can be shaped into wires. The following diagram shows different kind of wires which are made from these elements or from these metals. When they are passed through a small hole, and that is called a duct, then they can be converted or they can be shaped into wires. Therefore, we say that these elements are ductile in nature. Thanks for watching this video. My YouTube channel is Kimsol by Shinwari. If you have not subscribed yet, please subscribe my channel. Thank you very much.